Hello and welcome back to unemployment day 4. Big day today. Um, Today I was struggling to learn pointers really. I glossed over it before and I was trying to implement this code and I had a lot of pointers and I just wanted to double check that I could understand it. So what I'm going to do is open up a text editor and try and understand it the best that I can to myself basically. So pointers. What are pointers? Don't mind the dog. Pointers are. Pointers? What do they do? What do they do? Crap. Point to memory locations. Right, that's what I think. Pointer points to memory locations because that's where stuff is stored. Right? So then why are they useful? You can, user can access the memory location, which is more efficient than copying a variable, for example, and can change the value that the pointer is pointing to. So if I'm pointing to a variable x and x is 10, and I have a pointer, how would you write this? You would do pointer, which is pointing at the memory of x. So that's what it means, is the memory address of x. So if I was to change the pointer, or I could dereference the pointer doing something like this, pointer equals 15, so that would dereference the pointer, right, and changes this value to 15. So this is useful because now I haven't got to do this. I could, like, the same thing could be done if I do that. But it's just going to be the same outcome anyway, and it's more efficient to do it like this. And yeah, so that kind of makes sense. So pointers, what do? They point to memory locations of variables, I assume. Why are they useful? User can access the memory location, which is more efficient than copying a variable. User can access the memory location. Yeah, sounds right. And they can change the value that the pointer is pointing to. Yeah, true. So, example. I do have one here, but I'm just going to get rid of that. So, let's think of an example. This is in Go, by the way. So, if we define a variable number int, right, we say number equals 20. If I do pointer equals the memory address and of number, that means pointer would be equal to, if I go here, pointer would be like 0x, you know what I mean? So that points to this address value. So if you were to like print pointer, you would get this, right? But then if you do dereferencing of pointer, no wait, if you do this instead, you would get 20 because it's pointing to the memory address and then dereferencing it, which is going basically inside of it. Cool. Okay, that makes sense. So in unemployment day 3, I was doing this basic to do. Where has it gone? This is it in here maybe? No, it's probably this one. This basic to do here, but I found a book that goes through it, and I've been going through it on this one maybe. on this one, to-do.go, yeah. And uses a lot of pointers, so I'm going to go through every line and try and explain this so I can know that I'm going through it, or that I know that I understand it myself, because I just kind of copied the book willy-nilly, and I need to know that I understand it. So first off, package to do, this is like the API name to call from somewhere else. We have our imports. This is to save and access JSON files. This is to print errors, I guess. I think FNT is just outputting in inputs like prints, scan. This is accessing OS commands. So like args, which is the arguments that have been inputted through the command line, and then time is just a time library. If you know, you know, I guess. And then we define a struct, which I talked about before, but this struct is of an item, so a to-do list item. As to before, task was the same as description in the other one. Have my one, where is it? Yeah, over here. So task would be description, and we have completed bool here, done, and then created at time.time is task of type string, done of type bool, created at is of type time, and completed at is of type time. Cool. Then we have a type list, or it's called a type list of a slice of items, right? So this is used as the list of things to be stored in the to-do, which makes sense, I think. Yeah, type list of type a slice of items, yeah, because then you can make, because this is a what do you call this? What's this called in Go? So it's just a struct, yeah. keep getting my definitions wrong. So we have an add method for the we have an add method for the list object, for the list struct of list L, right? So let's try and explain this pointer here. So this pointer means this variable is pointing to a list object, a list, or pointing to an object of type list, I think, because that's different from when I said this, that's dereferencing, and this is the memory address of it, right? So this basically means pointing to the list, right? So if I quickly go, I'll just quickly pause this a second and double check that. Okay, so I need to change this actually because this is wrong. So we define this variable called number of type int, but we'd actually never define the pointer. So the pointer, you define, if I define it under here, you define the pointer as var pointer, so a variable named pointer of type pointer is pointing at a, or is pointing at a type of int. So we have a variable called pointer. This defines that it is a pointer, and this defines what it's pointing to. So this is pointing to a an int, right? Makes sense. So if I go back to the work, this is defining the variable. I'm not really defining it, but it kind of is defining the variable named L, which is pointing to an object of type list. So that makes sense. Cool. Now, in this add function, we add the task, which is of type string, which would just be the task name. So you'd say, as I said before, like make my bed, clean my clothes, stuff like this, and then we make a new item. Item up here is a struct, right? And then we just call it T. It's just T for task. T, or so yeah, I'm going all over the place. Let's slow down for a second. So we want to make a new item. So we need to have task, done, created at, and completed at all in this item. So you make a new object using this squiggly bracket here. So task will be task, done will not be done because you just made it, created at would be at time now, and then this is just a filler. right here. This is just a filler value, so it's not actually full up yet. And then we dereference the pointer L and append T to the pointer. So yeah, the appending works by I want to append to this. I want to append this to this. Cool. I probably say that under here. Yeah, append to slice and then elements you want to append. Yeah. So we append to the pointer of this because we do. Because it dereferences it and then you change the thing that it's pointing to. Yeah, cool. So this is basically the same thing here. All the pointer logic is the same. So we have a completed function where you input a number or you get given all your tasks in a list and you say, oh, I want to say completed task number 2. And you put it in here. And then you create a copy of the pointer list here. Then if it's just not if the number they've said is wrong, so it's less than 0, wrong, or is 0, then it's wrong. Or if it's higher than the length of the actual thing is, then return an error. Then you do I-1 because you just do. And you change it down to true. I think you do it because a list or a list of things is indexed starts at 0, not 1. So if they say I want to change number 1, you look at the index of 0. Makes sense. And then you change the completed time to now and return nil. So there's nothing to return. Then we have delete. This is the same thing with the pointer. But now I want to return an error, which is the same as this one actually. So we do the same copying thing here. I'm surprised that I don't know why you copy it though, because you end up changing it anyway. Maybe it's just good practice, I guess. I didn't write all this. It's just from a book that I copied. But so this checks the item doesn't exist again, and then this basically means you get rid of the item. So it's like looking append to I get it. So using the list, all the items before the item stay, and then all the items after the item also stay. Kind of makes sense. And we have save, which uses JSON. I'll show you what that does, but you save JS and error. So this is just the JSON text in here, and then you save it. Well, you want to save the whole list. If there's no error, or if there is an error, then return the error. But if not, then you return this, which just writes using the file name that we input here. Writes the JSON. I don't really know what that does. Just Google. That works. Then we have get, so that gets the whole list, which reads from the file. So if there is an error, and if the error is error not exists, I don't know what this is. Error returns from this package no testing against these errors, which is error dot is. Yeah. This just compares if this error is the same as this error, then do nothing. But then if not, do something. And then if there's no file, return nothing else. Return the whole file. Cool. I think that makes sense. Quite confusing my explanation just because I don't fully understand pointers still, but I think that me saying that has definitely helped so far. Can I make a new one without looking at it? Okay. So this is the exact same thing that I just said. So we have a var list of list strings, right? And then we have a var. I guess I probably could do it here, right? Can I do this? Bob, Jill, Jilly, Sally. I could do it there. So I do it there. If I define this variable here, how do I add to it? List. Oh wait. Oh, you just append. Okay, that was a whole bunch of things just to end up in the same place. I'll probably just skip through all of that I just did, but welcome back. So let's say I have this list, right, of things, and then I have a var pointer which points to a list of strings. Cool. Okay. Okay. So now if you want to set this pointer, we can do pointer. Oh crap. Pointer equals the address of list. Save. What's wrong with this? So then if we print pointer, we do go run. The pointer of. Oh wait, I'm being silly. No, wait, no. If I print that, what does it print? Right. And then if I print this, what does it print? Interesting, I didn't expect that. So this pointer just holds that, but then if I do this instead, dereferences it. Yes, that's not the address of this. This is actually it. So if I say, if I go here and I go, so I don't think you can change this. If I go, look, this is not going to work. I don't think. If I do this equals Tom, yeah, because this, look, it's not. This is trying to change the memory location. Cannot index pointer of type string. Yeah. Right. So that doesn't make sense. But if I do dereferencing of that, save it, please. Cannot index pointer. What? Really? What do you mean you can't index the pointer, mate? can't index a pointer. Yeah, but I'm dereferencing it, so I'm pointing to the list of things, am I not? Damn, I'm getting so confused now. Maybe I was wrong. Am I getting everything wrong, kind of? Cannot index a pointer. Write P to dereference the pointer. It needs brackets? Really? Okay, well, I didn't know you could do that. That's cool. Okay, so I guess that works. So, I don't know. Why would I need to use brackets? So, with my example, finally getting my example right, brackets to the dereferencing of pointer, 0 equals Thomas, same as the text thing, I think. Yeah, I was pretty close, but I got it wrong. And then you run it again, and now it should, if I just run the whole thing, whoops, Thomas. Wait, I didn't save it. Whoops. Right, and now I do. That's so interesting. It doesn't tell you the. I guess this is the memory address of all this. Is what this is telling me. Cool. So yeah. Now I think that's pointers down. Pointer. They point to memory locations of variables or of just of things, I guess. Why are they useful? You can access the memory location much more efficient than copying the variable. Change the value that the pointer is pointing to. Yeah. So then you need to define the variable, define the pointer to that variable using this is the name of my pointer. I am a pointer, and I'm pointing to type int. Cool. Now you set the pointer using a memory address, which is this and memory address of number. This is wrong, but it's fine. And then if you print the pointer, this is dereferencing using that there. Cool. Interesting. I think that makes sense. So yeah. So now I do understand this now. I do understand why this works, because this is telling me I am variable L. I am a pointer pointing to a type of list. And this is dereferencing here. But I don't think this uses and here. No. So it doesn't actually use any memory addresses because this is not the main. This is the API that I said before. This is the API to call from somewhere else. So if I go in here, you would pass in. Do I use it yet? No. Eventually, when you were gonna, if you had a list, if you had a list of things, I guess you would pull it in with, you put it in there with the and. Okay. Cool. Alright, so that was day 4 of unemployment. Today I just got very confused about pointers, but now I understand it. So a pointer points to the memory address of something, and you can reference this so you haven't got a copy, and then you can change the original pointer by dereferencing it. Cool. And then I was just explaining this to do file here. So I know how that works. Mostly, I don't really know everything about OS and all these libraries yet, but I guess just the more time you spend in them, the longer you understand it. I'm kind of sad that I did find the exact thing that I was going to make. Like, my idea was this to make this. It's not my idea, obviously, it's not original, but like, I didn't know that there was going to be a to-do list in this one book that I decided to read, but yeah. So, it's kind of annoying, but then at least it'll give me some understanding, and then I'll try and make something else afterwards so that I don't actually have to use the book anymore. But yeah, that was day 4. Hopefully a quick one. It says I'm recording for 30 minutes, but hopefully I'll cut that down in half. So I'll see you for day 5.